चंद्रयान 1, चंद्रयान 2, चंद्रयान 3 इसरो द्वारा किए गए ऐसे ऐतिहासिक प्रोजेक्ट. Americans would say that if you find water on moon, you will be called as Moon Man of India. And you found water on moon. Wow.
Chandrayaan has found a water on the moon, and I work for that. My team has worked for that. Put together, very, very modest budget. I think our satellite cost was not even 100 crores.
So the idea was that if we announce a mission to moon, people will be more interested in doing this for our own country instead of going to other space stations. And that is how the Chandrayaan series begins. How difficult was it for a scientist out of India to be able to send something to moon and land it there? Because nobody in India has done this before.
The launcher this time cannot be PSLV. By that time GSLV has come.
Okay.
So GSLV
it's a much better rocket.
Much better rocket. Because those you have to carry a bigger mass. GSLV launch in India, orbiter by India.
Lander by Russia. Nobody has landed there before.
Nobody has landed before.
India is in the race. Russia is in the race. Russia's goal is to only land. Our goal is to land and explore. So
but
Chandrayaan 3's budget is less than Chandrayaan 2's?
Okay. Chandrayaan 3 cost is less than Chandrayaan 2. People are talking about a possibility of launching the launch vehicle from moon to Mars. Correct. Mars colony also we are talking about that.
So moon is going to be a station in between. So
but
if we miss it, we are gone.
We miss it, we are gone.
We cannot fix it. We cannot chase it.
We cannot
do anything. If we miss it, we are gone.
Correct. That too, when we are aiming for a polar orbit, you cannot miss it even a minute.
We cannot even miss it for a minute. हिंदुस्तान की जनता, एक बार फिर से स्वागत है आपका आपके फेवरेट पॉडकास्ट जेके सुपर पॉडकास्ट में. और आज जो आइकॉनिक प्रोजेक्ट हम लेके आए हैं उस पे हम नहीं, दुनिया यकीन नहीं कर रही थी कुछ वक्त पहले तक. चंद्रयान 1, चंद्रयान 2, चंद्रयान 3 इसरो द्वारा किए गए ऐसे ऐतिहासिक प्रोजेक्ट जिनके बारे में सुनकर ना हमें सिर्फ खुशी होती है बल्कि गर्व भी अलग लेवल पे महसूस होता है. और आज जो मेरे साथ गेस्ट हैं वो कौन है वो? ही इज द मून मैन ऑफ इंडिया. हिंदुस्तान की तरफ से वो आदमी जिन्होंने पहली बार चंद्रयान को चांद पे उतारा, चंद्रयान 2 को बहुत क्लोजली फॉलो किया और चंद्रयान 3 को भी. डॉक्टर मिलस्वामी अन्नादुराई सर, वेलकम टू जेके सुपर पॉडकास्ट. फर्स्ट ऑफ ऑल, आई वुड लाइक टू अपोलोजाइज टू यू बिकॉज माई इंग्लिश इज नॉट दैट गुड. So I will try my best to understand things in English, sir, but it all depends on you. Okay, sir? How are you, sir?
Okay, mine also not that good, but still anyhow we will make it.
No, sir. Your English is pretty good, sir.
It's basically I'm doing well.
Yeah.
I think my visit to Delhi is good. All the way flying from Bangalore and being with you.
Correct, sir. When I was researching about these Chandrayaan missions, I came to know that you are known as the Moon Man of India. Why is that so, sir?
Yeah, this is how jovially my colleagues from NASA, when we were working for Chandrayaan 1, I think they used to call. That's how I think finally it's coming out with the media. Media also looking into that. And that's how I think probably it happened to that. Because I used to talk about if water is there like that.
Okay.
From the preliminary design review onwards, I used to tell like that. To start with, people used to be sarcastic. Whether the moon is barren, how water can be there? Why you are carrying instrument? If at all,
Nobody believed.
If moon contains water, I think definitely will be called as a moon man of India.
Wow.
Because you are so much scouting for that. I think that's how it is.
Americans would say that if you find water on moon, you will be called as Moon Man of India. And you found water on moon. Wow.
Chandrayaan has found a water on the moon, and I work for that. My team has worked for that.
Correct.
But definitely somehow or other at the insight, somehow it was having a feeling that I think moon may be having water. Because moon supposed to have gone, at least a part of the moon supposed to have gone from the earth. When Mother Earth is having so plenty of water,
correct,
a system which has born out of Earth,
absolutely,
also should have that.
Correct.
That's what I was.
So you were confident that moon might have water.
Yeah. But I used to tell them if the whole moon has to be seen with so many instruments, if all the instrument tells no water, then only we can tell science point of view, even to tell no water on the moon, you have to carry instruments to search for water.
Correct.
If all instrument tells all part of the moon no water, then let us declare no water on the moon.
And so
if water is there, then if all the instrument confirms, one instrument tells you will not tell that.
Correct.
So that means if you have a couple of instruments, that instrument tells your own way, yes, the water presence of water on the moon, then it confirms. So either to confirm no water, to confirm water, I think both ways, I think we should have proper mission. Mission should have proper instruments. I think that's how we configured it. I think we have done it.
We've done a fantastic job over there, sir.
Yeah.
Before us, there were so many missions to moon, and so many people, like some men also went to moon, but nobody ever found water. Why is that so, sir? Why were we the first one to find water?
Yeah, first and foremost, the moon was not explored in totality.
Correct.
It is only some few places that it has been done. And even the man when landing also, it's only few square meters he has gone around. Okay, not even few square kilometers.
Just a few square meters.
Yeah. And because they were there only few hours in the place and in the process.
Correct.
Implanting some instruments, putting the flag and taking pictures. I think that's how it's happened there. And taking samples from there and here and there. And you cannot afford to have so much away to not to lose a communication. Now you look at here Pragyan. Pragyan cannot go more than 500 meters, 600 meters.
That's
so
it.
Then it cannot lose its communication with the mother craft.
Correct.
Same is the case even man lands also. So that's how it happened there. So that's why everything is localized. So now if you think about our Mother Earth itself, somebody comes and lands in Tar, somebody Sahara. So they will tell that the whole, if you go back and tell,
there is no water.
No water.
Yeah,
so that is not the
reality.
So unless service is the whole moon, we cannot see. But that's what we have seen is we have mission configured like that. We can see the whole moon. Because I think those 70 missions have gone to the moon. Ours is a full-fledged polar mission around the moon.
Sir, please explain that. What is a polar mission and what are the differences between the other 70 missions and our mission?
Yeah. You assume this is the moon.
Okay, sir.
Perfect. Now from here to there, from Earth you are moving. From my place you are going.
Okay.
Move the Earth and go around this place and land anywhere here.
Okay.
This is what happened there.
Okay.
That means you from here you go, what you can see the place, that place only you are landing, and for that you go around and come here.
So those 70 missions were
everything you looking from here what I can see.
Okay.
And only this regions.
Okay.
But nobody bothered about here. Nobody bothered about this. Nobody bothered about this side.
Okay.
Now our mission is not this way. Our mission is to go different. This the path.
Backside of the moon.
No, go around the moon, pole to pole.
Oh, pole to pole.
Now, moon itself is revolving on its own axis.
Correct.
28 days it goes around.
Correct.
So that means if you keep on revolving like this, you yourself keep on moving, moon is keep going like this. This gives you an advantage point. The whole moon can be swept using 11 different science instruments.
Wow.
Looking at 11 different way. So that none of the previous people have done. Okay. The one thing is, the mission gives an opportunity. Then the time of 40 years later gives a good amount of instruments of latest instruments.
That's true.
Which normally we'll use. So all putting together, I think we had a good number of instruments, good mission, put together, very, very modest budget. I think our satellite cost was not even 100 crores.
Our satellite was not even 100 crores.
Yeah, because the hotel project was 346 crores. That includes 120 crores for ground segment and another 150 crores for the PSLV XL development to take place. Another some amount for the science data center to set up. Some amount for operations.
Correct.
Finally left with to make the satellite is hardly 100 crores.
So rupees, what I'm understanding, sir,
rupees,
in 347 crores, we kind of created history by finding water on moon,
starting from scratch,
which before that 70 other missions could not do, where they have spent way more money.
Way more money.
That is incredible. And you were responsible for that project, sir. If I
my team was responsible for that.
That's amazing, sir. And that is Chandrayaan 1.
That is Chandrayaan 1.
Chandrayaan 1. Its objective was to find water on moon, sir?
No, Chandrayaan 1 objective was slightly different. Basically, around that time, you could hear ISRO was coming from the experimental to operational phase.
Okay.
That means we made experimental launch vehicle.
Okay.
Experimentally of the small science mission, small remote sensing mission, small communication mission. So now these are all, we have done that. So then the government is asking, when we went to government, we can go for operational.
Correct.
That means our Doordarshan, we can have our own thing. Our telephone telegraph, we can have our own mission. Remote sensing, we can have our own mission. Whether meteorological, we can have our own mission. So that calls for a good number of missions to be realized in operational mode.
Correct.
And the launch vehicle also coming up, that also each thing you would launch for so many. So that means you need a good budget.
Correct.
So when you are going for that, one side government was willing to go, but another side we had an issue. of IT was booming up
all across the globe.
All across the globe. So we're finding it difficult to get new talents in a big way. And even the existing talents within ISRO also are trying to go out.
Okay.
So that is the juncture, but we have to go for operational arena. So wherein system expects you to deliver more systems.
Correct.
So what to do? To enthusiast the people both inside and as well as the enthusiast the people to attract the new talents.
Correct.
We thought something to be done different.
Okay.
What is that? So an idea came whether if you're going to the moon, whether that will make the people to work for some focused way,
for ISRO?
Enthusiast the people in ISRO.
So the idea was that if we announce a mission to moon, people will be more interested in doing this for our own country instead of going to other space stations. And that is how the Chandrayaan series begins.
Yeah, that's how Chandrayaan series begins. And we wanted one mission, but we had the proposal. Government to start with so many questions agreed with all the deliberations. Finally, the Prime Minister of India, then Prime Minister of India.
Who was it, sir?
Atal Bihari Vajpayee.
Mr. Atal Bihari Vajpayee.
And he put that Chandrayaan, YAAN, one A added there.
He added one A.
He added.
Okay.
Then after a pause, I think he added one dash and he put one. Made it Chandrayaan 1. We went for one mission Chandrayaan and he came as Chandrayaan 1. 1 means you need 2, 3, 4 also. Then we thought about something more also. We have to think about. Originally ISRO was thought about making one mission.
So
Enthusiast the people.
That dash and 1 made it a series of missions.
Exactly.
And that is the idea of late Shri Atal Bihari Vajpayee ji.
Yeah.
That was
really, I think, I don't know how it came. That visionary thought. The dash 1, I think, made the whole thing is back. Now you look at here. Now it's a vision called Back to the Moon. Not only by India, the whole world is thinking of going to the back to the moon. After 70s, they stopped going to the moon. This Chandrayaan 1 made a difference. Discovery of water on the moon. The dash 1 made us to go to 2 and 3. This 2 and 3 already is triggered the whole world beyond even Indian masses. So the original objective of attracting the talents, retaining the thing, 100% we made it.
Wow.
100% we have made. But beyond that, what has come out today is something I don't think anybody of us dreamt about that.
That's so incredible, sir. Now let's talk about Chandrayaan 1.
Yeah.
Sir, how was your journey with Chandrayaan 1?
Yeah, I think before Chandrayaan 1, I had an opportunity to work with India's experimental mode of satellites, remote sensing.
Correct.
And coming into the operational era wherein the satellites used to be done outside and launched from outside, but overseas how to manage. I think that's from there slowly I trying to continue operational era now.
Correct.
So in that time frame only, that is I joined early 80s, so gradually grown up. Under 82, now 88, 92 till sometimes came. So in the 90s, this problem came. So then I think having worked, probably I worked for, so at that point of time, I got expertise in the launching the satellites, and the satellites of the near Earth or the far Earth. And once the satellite launch doesn't mean it will be fault free. Some issues are other.
Absolutely.
Okay. Somehow I got the knack of understanding what is the problem of the satellite, even though very far.
Correct.
And not only understanding and localizing the problem, somehow able to circumvent and make the satellite to survive for long.
So a satellite that was suffering through a problem, you could detect that problem.
Correct.
That was based on intuition or knowledge, sir?
No, it is a knowledge.
It is knowledge. Okay, now you could detect that problem. And now you could fix it, and that satellite could serve for longer.
Correct.
Beautiful, sir.
Because the whole thing has happened because when I joined initially, the hardware are done from elsewhere, and we used to launch from elsewhere, as I told. Then I told, before we start doing, because this all started, I think if you go back even beyond that, just the first few weeks of my joining ISRO.
Correct.
I think the way I joined ISRO with so much of dream and expectation.
Correct.
But when I landed in the 1982, the ISRO was not as I was expecting, because it was between two industry sets. And it's mostly hired their industrial sets, and very, very modest satellites are making.
Correct.
And that too, most of the satellites are done elsewhere. And even the satellites, whatever we made, is also being launched from elsewhere.
Correct.
So what we are, and most of the time we have been asked to give a book, manual, with that to look for the satellite data and look for the signatures. Even in non-deviation, if whatever is written there, you follow that. Not there, you ask for somebody. They will tell you what to do. Then you should do. So for this, what is a big thing like that? I was
so it didn't feel much like a scientist.
Yeah.
Like
So,
you were not doing something that nobody else has done.
Correct.
You were not thinking.
Correct.
You were just replicating somebody else's work.
Yeah,
Right, sir?
I felt something. This is not the place what I want, what I was looking for.
Correct.
So then I wrote in stuff for telling this is not the place what I want to look like. Then I thought, what in this place what I can do. Okay, I scribbled some 2 pages. I told I understand to make the satellites ISRO it will take more time.
Correct.
But before that, why can't we construct a satellite in a software form?
Okay.
That is mathematical, the science all put together. How the various systems of the satellite can be simulated and how the interlinking can be done. Something like that. It's a philosophical note like that.
Correct.
I made and gave 1.5 page note. So just 2 weeks of my joining ISRO that happened. So then Director ISRO Satellite Center, Professor R. Rao, I gave this on one Friday. Monday morning, I'm getting a call from a section here. Professor Rao has written a very good proposal. Provided another is ready to take the responsibility, I'm assigning this responsibility to him. That means I told some suggestion and he has given back to me, you do it like that. Then it was really a lump sum. Then I sat together. So then I made a detailed project report as I can follow. So then I gave the proposal. The proposal was that time to buy some computer systems and what I can do like that. Around 7.5 lakhs was the budget. My salary was 700
How much was
rupees.
the budget?
7.5 lakhs.
7.5 lakhs?
But that time my salary was 700 rupees.
Okay, and 7.5 lakhs compared to today would be approximately around?
I told my salary was 700 rupees that time. You compare 4 lakhs of my salary versus this you can compare.
I cannot, sir. I'm not that good at maths, but I'll just think, sir, that I'll just take a random guess. Would be around 50 crores in today's
around
time?
Around that maybe that. Definitely not less than 20-25 crore.
Okay.
So that we're giving for a new entrant. That thing is really
and this is for Chandrayaan 1?
No. This is for to make a software. Whatever is scribbled that we can go for a software form. So that is the one to really to make it. I have to struggle a lot. We have to understand the intricacy of the various systems, how they will behave, how I can model it. Then many things we are trying to do that. Then this understanding only gave me when some problem comes in the satellite. So what does it mean?
So you simulated every satellite out there on the software.
Correct, on the software. So when we are doing all these things, so I could understand the intricacies of something. So something is paining. For example, something is paining. Doctor understands what does it mean using the symptom. So telemetry gives only symptom. But what is the cause? Okay, so that cause, root cause to identify. I think this is the one real backbone for me. So that is the one which helped me there. So this enables one side making a satellite, understanding the satellite, launching it. After launch, how it's behave. So this connectivity, then this I could improve upon from remote sensing satellite, communication satellites. This all put together. When Chandrayaan we can be launched like that, it came. 2003. August 15th, Prime Minister of India announces Independence Day as a national mission, Chandrayaan 1. That comes to me.
Okay. And that is why that mission came to you.
Yeah.
Wow. And then Chandrayaan 1's story begins.
Correct.
Then you get to that mission, sir.
Correct.
Now let's talk about the journey of that mission that Chandrayaan 1 begins.
Yeah.
How difficult was it for a scientist out of India to be able to send something to moon and land it there? Because nobody in India has done this before.
Yeah.
So what was that journey like for you, sir?
Yeah. This is really a thing, even the scientific circle, engineering circle also. Because 40 years back, they have gone to the moon. But 40 years later, nobody, because that moon is a barren. So that means now when we go, if you go the same way, if you follow, so we have not gone previously. So one possibility is how elsewhere people have gone. You follow their path. That is one way of going. But if you follow the same path, possibly you will get the same answer. Moon doesn't have anything. To tell the moon doesn't have anything, why to spend the money? So we cannot follow that path. If that is not the path, then what is the other path? Okay. That means you have to do on your own. And you don't have a good expertise. And your people, most of my people are all very normal engineering colleges they have studied. And that's how. And budget also, we cannot ask for a big budget. Because this is the mission objective is to enthusiast the people, So with that, more than 350 crore asking is not good enough.
Correct.
So, but 350 crore, you have to make everything on your own, because it is not only the launching the satellite, not only reaching the moon, ground system. So until then, we had a missions not more than 36,000 kilometers away. 36,000 kilometers away from Earth.
Okay. And the distance of moon is?
Moon is 384,000 kilometers. More than 10 times.
36,000 kilometers is probably around the orbit only?
Around the Earth.
Around the Earth, in the orbit.
Geostationary mission communication.
Correct.
So now we have to go more than 10 times more of that. So in a nominal sense, square of the distance, complexity of the communication from one place to another place increases with the square of the distance between the two objects.
Correct.
Okay.
Correct.
Now, previously, your communication is only up to 36 kilometers. Now, it is more than 10 times far away your moon. So, none of the existing ground systems will work. You have to make on your own fresh.
And you cannot buy because you don't have the budget.
Yeah.
You have to make everything on your own.
On thing. And with that 346 crore you should do. And again, one is this. Another thing is when 2003 end they are given. 2004 only budget comes.
Correct.
But with the understanding, 2008 we have to realize this mission. That means within 4 years you have to realize the mission also.
So there is a time constraint.
Time constraint is there.
And there is a budget constraint.
And another thing is expectation is more. Because 70 missions I have not seen. Something you should see in your first mission.
Sir, sometimes I fail to understand. What are we like? Are we absolute geniuses because we get less time? We get less money. And the expectation on us is something else only.
Yeah.
And then we deliver also.
Yeah. So then looking at all these things, I think the whole world was laughing, which I felt what is the whole world. Okay. The people from NASA, people from other countries.
Anywhere you would go?
Anywhere you go, people are laughing. Other these people are really serious or what they are talking about. I think that was the case.
And then happened a conference in Udaipur. Where a movie thing also happened with you.
Yeah.
What was that?
Yeah. So then when we are putting the things together, somehow Dr. Kalam used to tell, you should dream for something. Even Swami Vivekananda also used to tell about. You take one idea, you live with that idea, eat with that idea, you sleep with that idea, you die with that idea.
Correct.
Okay. That means you should do that. So something, you created a thing. So I made a video that time itself. How we will send the using a PS. And again, our PSLV is a modest in the world.
Correct.
Other places, launch vehicle is very big. We don't have big launch vehicle also. So with this launch vehicle, going to the moon, path in which nobody has gone, we have to do. With the money which nobody has spent, with the less money you should do.
Correct.
Budget also less. Time also less. But how to do it? So we made it here a video. That video was made in a conference in Udaipur. That was the lunar conference, international lunar conference.
So scientists from all across the globe were there.
All there. And we are telling this is the mission we are going to put it. And putting that video was there. Almost the whole hall was laughing. These people are doing like kids, they are playing a video. They have to go to the moon. Instead of going to the moon, they are putting a video. What does this mean? Okay, they let them be happy with the video. I think that something like that. Only people thought about that. But somehow I was trying to tell the whole my team. You think about this. Yes, we are going. We have to make reality each and every step of this. Each and every step of this, you have to live with that step.
Correct.
So everybody connected in that when you put the whole idea is with the 25 minutes video, everybody could connect what part of that mission he should do. I think that is the main essence of my making the mission.
Correct.
So the whole team supposed to get aligned with the whole purpose. I think that's how we have went about that.
Now, sir, we have launched Chandrayaan 1. Chandrayaan 1. It goes into the orbit. I think we are taking the slingshot approach.
Yeah, same.
Everybody has to take a slingshot approach.
No. That also is our own thing, because I told we had only the PSLV around that time.
Okay.
With the PSLV, one shot going to the moon, not possible. PSLV has capability, can throw only around 1300 kg system.
Okay.
That to maximum of 22,000 kilometer orbit away from the Earth.
And have we divided it into first orbit, second orbit, third orbit, fourth orbit, or something like that?
No. Whatever you give the mass, this mass maximum 1300 kg.
Okay.
At the maximum, it can put it in
22,000 kilometers.
22,000 kilometers.
Okay.
For nearer 200 kilometers, 200, 240. So this is the orbit it can go.
Correct.
But now you have to go to the moon, which is 36,000 kilometers.
Okay.
So that means in the 1350 kg, you need minimum 850 kg fuel gradually to take it, using even along with the, that much only we can take. Because to go to the moon and do all the things, minimum 500 kg you need for satellite to make.
Okay.
That means it left with only 850 kg of fuel.
Cool.
With 850 kg of fuel, you have to go from 22,000 kilometers to 36 kilometers.
30?
384,000 kilometers.
384,000 kilometers.
So that much to go with this fuel also not possible.
Not possible at all.
So then we have to make use of the effect of the gravity of the Earth also.
Correct.
So that incrementally improve the orbit.
Okay, and increases the speed.
Increases the speed. Some 5-6 revolution you do. While you're doing it, you gradually improve. And are you doing it properly also, you can verify.
Correct.
If any small mistake, next orbit I can correct it.
Okay.
In terms of gyro, in terms of the thrust value, those you can correct it there. So those things also, that provision also there.
Correct.
Then you can reach that also. So that gives you, with the PSLV, its capability, what minimum weight you have to take it to the moon.
Correct.
With that, what is the fuel available? With that fuel, how to reach? We have to have our ingenious way. So this way is full India-made system.
Nobody else did this before.
Nobody has done.
So how would they do it, sir? They would take it to...
They have the very powerful rockets. The powerful rocket can throw with a one shot to the moon orbit or Mars.
Directly, without any orbiting and all?
No.
That is the kind of rocket they
have. That is
had.
the kind of rocket they have.
Okay.
So that has more than 10 to 15 times powerful than us.
Okay.
Accordingly, 10 to 15 times more costlier than us also.
Okay.
Both are there. But we don't have that. Okay. But we have to realize this with the available thing.
Correct.
So with the available resources, but still making the target. I think this is a real ingenious way. But as far as I am concerned, engineering point of view, this gives a foolproof method. Because incrementally you are improving. If any mistake, you can correct it next turn.
Correct.
So that gives a handle on
So it is a better method also.
It's a better method.
Then directly sending something to the moon.
Correct.
This method saves you money. It takes a little bit of more time.
More time. That's it.
But it saves you money. It lets you correct any mistake that has been made.
Perfect.
So then we take this slingshot approach. Now, sir, we have launched towards Chandrayaan 1. We have launched towards moon. It's on its path.
Correct.
What are the things that how much are you in communication with that satellite?
Okay,
And what is happening during the process until it reaches the moon's orbit, and how much time it takes to reach to the moon orbit, sir?
So basically you look at here we would have taken so much of time, a month or so we'll keep taking.
Okay,
but
sir.
Once from here you sling it, it is less than a week.
Less than a week.
Less than a week only you take. But during the course also, so we would have predicted each hour where it's supposed to be.
Correct.
Whether it's going that path or not, keep on watching.
Okay.
Keep on watching. If any problem, if any small deviation, we will correct it then and there.
Correct.
Okay. This is how we are allowing. So that when we are launching it here, even during that time frame, you look at here, within 28 days, moon comes around the Earth.
Correct.
So when you are throwing it, moon was not here. Moon was supposed to be somewhere here. Moon is moving around the Earth.
Correct.
With the speed of nearly 1 kilometer per second.
1 kilometer per second.
Every kilometer, 1 kilometer. So 7-8 days when you travel here, you cannot afford to have a delay or ahead more than 10 minutes.
So everything has to be on time.
So that will be checked whether it's properly going or not.
Okay.
If not going, you have to minor correction.
Okay. So but if we miss it, we are gone.
We miss it, we are gone.
We cannot fix it. We cannot do anything. If we miss it, we are gone.
Yeah, correct. That too, when we are aiming for a polar orbit, you cannot miss it even a minute.
We cannot even miss it for a minute.
Because now what is happening, I told, this is coming like this. Okay. When it's, but you are going and you have to go, cannot go behind. You have to go over, go like this and take a turn, come like this.
Okay.
You have to come almost like a point. That called pole. Then only you reduce it here, it will acquire like this around the moon. You are going like this from Earth.
Sir, I got it.
You are going from Earth. Okay. Then it normally allow it to have turn. Once it turns, here you reduce the velocity, it captured by the moon.
In its moon's gravitational force.
Now let us assume you delayed by 10 minutes. 10 minutes means 600 seconds. 600 seconds means 600 kilometers. So you are away from that target 600 kilometers. Your chances of acquiring around the pole not possible. As simple as that.
So we have to get it
Get
right
it.
even to a minute
Yeah.
to reach to the pole.
Reach to the
If
pole.
on this surface, on the
Here it is not an issue. Here what is happening is if you go over here, okay, here or there, whatever it is, you can acquire and afterwards you can come back.
Correct.
But now you miss the pole, you cannot get back the pole easily.
So we take on a challenge. That has the least amount of money.
Correct.
The least amount of time.
Yeah.
Not so many enthusiastic people before that.
Correct, yeah.
And then we have the most unique mission to find water.
Correct, yeah.
And then we have taken such a challenge that we cannot go late by even a minute. That too, we are talking space terms.
Yeah, exactly.
This is not Earth. This is not a city. This is space. And we get that right. There is a reason they call you Moon Man of India, sir. That is the reason they call you Moon Man of India. That is so incredible.
It is really a very, very, very good, great teamwork. That's why I told that movie.
Correct.
Every one of our people lived with that movie. Video, whatever I took.
Correct.
So that when it really happened, yes, whatever we thought about it has happened. Like that, people could see that. Because the 4 years, 2004 to 2008, they lived with that idea.
Correct. And then we are in Moon's orbit.
Yeah.
Now, first time in the history of India, we are going to be landing on Moon.
Yeah.
We have chosen a site, sir, before only?
No, basically Chandrayaan 1 itself we have chosen a site.
I'm talking about Chandrayaan 1?
Chandrayaan 1, yeah.
Okay.
That also we have chosen. Actually, that is even closer to the pole compared to now.
Yeah.
So that place basically it goes over there. So then we have on 35 kg another probe and the mother craft. That will be separated from the mother craft. And there is a small micro thrusters. Micro thrusters will fire. Once it fires, it takes away a portion of its orbital velocity.
Correct.
Around 75 meters per second velocity it will take. Once you take the velocity, no longer it can be in orbit. So any object to be in orbit around a mother planet
it has to have certain speed.
Some certain speed, certain height has certain speed.
Correct.
If that is not there, it will fall. So now we attained this orbit. From the orbit, you take a separate 135 kg probe. That probe has its own small thruster. And coming out of that, it fires. It removes the velocity around 75 to 80 meters per second.
Per second.
Per second. So then it cannot sustain in the orbit.
Then it loses height?
Height, it falls.
Okay.
It falls. 27 minutes, it keep falling. While during the fall, actually we kept some 3 instruments in that probe also. One such instrument is called mass spectrometer.
Mass spectrometer. What is that, sir?
The mass spectrometer is to, for example, here also many cities, metros would have seen that. Come out of the airport, railway station. It tells about the percentage of carbon monoxide, carbon dioxide. It tells basically in the atmosphere. It tries to tell what is the composition of the thing.
Correct.
So we carried that. As people laughed, Moon doesn't have an atmosphere. Why are you carrying this?
I
Originally people
understand.
laughed. That doesn't. But this instrument, and it was almost silent from 100 kilometer on calling. But 70 kilometer onwards, it started showing some symptoms.
So there was some kind of atmosphere there.
Yeah. And it keep on pronouncing and keep coming closer to the Moon. That means Moon is generating something called tenuous atmosphere during the so-called daytime of the Moon. When sunlight hits, gravity being less, it hits very nicely, and that reflects something that comes. In that we have seen pronounced mass number called 18.
Okay.
In the mass number 18, hydrogen has a mass number 1, oxygen has mass number 60. 2 hydrogen, 1 oxygen can explain 18. So we are seeing a water there. That water should have come from the surface only. Okay, so that means first indication after reaching the Moon.
Correct.
When we are thrown this object itself, we got an idea.
And it's going towards Moon. It's going to land on Moon.
Yeah, land.
And while going, it's showing you symptoms of these elements
in the atmosphere.
And it's
supposed to come from there only.
Using the word right, if it's evaporating the atmosphere, is in the daytime only. Okay. So, and then from that we can figure out that there is evidence of water over there.
Then subsequent instruments are subsequent months, we are closely watching that.
And the world has asked us not to send this instrument because they don't believe there is any atmosphere.
There is no atmosphere.
So the world is not to be believed ever at all. no scientific agency has to be believed ever at all, except if ISRO is saying we can find something, we will find something.
No, science is all about questioning.
Correct.
Basically, the idea is from our childhood, we have been taught about that moon doesn't have an atmosphere.
Okay.
But still it needs to be questioned. I think that question only, it was, we created that question, part of Chandrayaan 1. So first instrument gave the answer. Yes, the question has an answer.
Correct.
It has an atmosphere.
Okay.
At least generates an atmosphere. So then we are trying to see the other instruments.
Okay.
And then one by one, that's keep coming out.
Okay.
Hydroxyl molecules in the surface, and in the coal trapped place. That is in the pole, in the moon itself. Near the poles, a few kilometers depth, some of the craters are there. Those craters, we have the grazing angle of the sun. So that means in the deep into that. So now the sun is grazing, it cannot go inside.
Okay.
It cannot bend and go. So that is always being a dark. So that dark places, this water particle, whatever goes, it gets settled and preserved as a ice for ages.
For ages.
Ages. So now we have set of another instruments. That instruments can penetrate through this darkness and see what that place contains.
Okay.
That gave the signals of water in the form of ice.
This is also in Chandrayaan 1 only,
Chandrayaan 1.
So long back in 2008, we had so much discovery about water only. So we got it in the atmosphere, we got it in those craters. Then?
So then we have seen in the surfaces also, where the sunlit portion also, OX molecules, hydroxyl molecules. So that probably indicates what would have the mechanism of, one of the mechanism of water getting formed in the moon. Possibly.
Okay.
Because you look at here, even Chandrayaan 3 now talks about oxides. That may be silicon dioxide, it can be titanium oxide,
correct,
iron oxide, like that. So now from solar wind, hydrogen ions comes and hits. Solar wind consists of good amount of helium-3 and hydrogen ions.
Okay.
The hydrogen ions hits on the moon, it knocks out the oxide and it forms an OH.
Okay.
Hydroxide.
Okay, hydroxide.
So one more hydrogen falls on the OH, it can form H2O. So this can explain a new mechanism of probably how moon is collecting water. There is one mechanism.
Forms its own water.
Own water.
Yes.
That is the only way we can explain. In the sunlit region of the moon, abundance of OH molecules and H2O molecules.
Wow.
So then this gets evaporated. That explains how what we have seen in the atmosphere. And that has to fall, because that is not coming all so much. It is keep on coming down up to 70 kilometers. That means it has to fall somewhere once again. When the place where it's falling happens to be this cold trap,
correct,
it will not come back.
Correct.
Okay, so that settles for ages. So it can explain how there's so much of ice, so much of depth it is there. It can explain.
So there is evidence for water in the atmosphere. There is evidence for water in the dark places, and then there is evidence for water on the sunlit region as well. So there is enough compelling evidence all across, like with ISRO, to send another mission.
Correct.
And this is what we have found from Chandrayaan 1. Now, after all this evidence, we decide to go for Chandrayaan 2.
Correct.
Now that dash and 1 goes to dash and 2, right, sir?
Yeah, exactly.
Now Chandrayaan 2 happens. What was the objective of Chandrayaan 2? There is a lot of, we happen to know more about Chandrayaan from Chandrayaan 2 because the social media had come into play.
Correct.
The media industry had become much bigger.
Correct.
Everybody was talking about the pride of India. So then we get to know about Chandrayaan 2. Sir, explain what was Chandrayaan 2, how was it different from Chandrayaan 1? And was it a real failure, or was it a failure to a small extent and most of it was successful? Look
at here, Chandrayaan 1 when we made. Anyhow, there is also another side story wherein along with us, the good number of foreign countries also joined. Is a part of instruments
in Chandrayaan?
Chandrayaan 1.
Okay.
That means we carried 6 instruments. Remaining is equal number of instruments to come along with us. Some 2 instruments from US, one from UK, one from Bulgaria, another one from Sweden. JAXA like that also.
So when everybody was laughing, they said now that if they are going,
opportunity, they want to make use opportunity.
So they are saying that they are going, let's put our instrument also in their satellite.
It gave. So those instruments were there. But unfortunately, Russia was not part of that.
Why?
Chandrayaan 1. Because they gave a very bulky instrument that we could not accommodate.
Okay.
So, but then in the close skill of Chandrayaan 1 itself, we started thinking about Chandrayaan 2.
While you were...
2008 we launched this, but close scale of that we started talking about Chandrayaan 2 also.
Okay.
Chandrayaan 2, now obviously, because of various reasons, Russia was coming as a partner to us.
Okay.
So then, that is because they were not partner here, they're coming here.
Okay.
But Chandrayaan 1, as it is, we cannot repeat that. So now having gone orbiter, what would happen Chandrayaan 2? Chandrayaan 1 has one small impactor, but that is only up to hitting on the moon surface only, it survives.
Correct.
But now is it possible for us to have a soft landing system? A landing system that lands softly.
Sir, sorry, just to cut you in between. Chandrayaan 1's landing won't be called soft landing?
No. Chandrayaan 1 is a crash landing.
Okay, so we crashed, and while crashing, we got the evidences.
Evidence.
Now we wanted a soft landing where our satellite would sustain.
Correct.
Okay, so soft landing was happening for the first time.
It's a logical extension. Okay. It's logical extension. Whatever we have seen is predominantly is before going to the surface.
Okay.
What all you have seen.
Okay.
From 100 kilometers, you are going. You see, until you go only you are seeing.
Okay.
But you are not seen in the place.
Once there is impact, it's over. In Chandrayaan 1.
In Chandrayaan, it is like your coffee, your tea smell I'm smelling.
Correct.
Is different from
drinking it. The impact it has on the tongue. Okay, I got it.
So like that, so you can't be softly land and see. So that's how Chandrayaan 2 came out.
And the trajectory we took was the same?
Exactly the same.
Exactly.
The
budget, difference in the budget?
Yeah, difference in the budget to start with was not much.
Okay.
This 346 crore has become as a 420.
That's it.
Very, because that is for 5 years of that thing only.
Okay.
Otherwise, it's less because now it is an additional system called lander. That cost is added.
Okay.
In the orbiter, not much. Lander it's added, but lander to be tested. The test facility you have to build up now.
Okay.
That facility. So the cost is meant for only that way.
Okay.
The launcher this time cannot be PSLV. By the time GSLV has come.
Okay.
So GSLV
it's a much better rocket.
Yeah, much better rocket because those you have to carry a bigger mass now.
Okay. And what was the mass of this Chandrayaan 2?
No, this Chandrayaan 2 mass will go around 2,800 kg.
From 1,300 to we went to 2,800.
Yeah, 2,000. Okay. So when that mass comes to take that GSLV, anyhow by the time GSLV also.
And GSLV could launch it to what distance?
36,000 kilometers.
So that could do it to 22,000?
22,000.
This could do it to 36,000 kilometers. Okay.
So that's how it has configured and we have gone. So until up to reach the polar orbit, trajectory remains same. So now afterwards, previously we have thrown a impactor that came out and it reduced velocity and it government fallen. So this time, until then it's same. But now the lander has to be separated.
Correct.
After separating, but it will go, it's incrementally reduce its orbit.
Correct.
Such that it attains a particular place. So then towards the target to go, it has its own defined path. It's a controlled path. This time it's a controlled path. Previously it's only gravity fall.
Correct.
Now it's a controlled path.
Correct.
Like aircraft is coming and landing
Absolutely.
on something like that. Okay. Now you identify a target place, which could have been around 600, 700 kilometers away. So now you start from height of around 30 kilometer height. From 30 kilometer height, you have to go here and land. So it go reduce the velocity.
Correct.
Reduce the velocity, you go here. When coming over here, you turn like this and land softly.
Okay.
This is the in a macro
and
level.
You reduce the velocity by firing thrusters and all.
But to do that, previously we had only one micro thruster removed the velocity in previous thing.
Okay.
But now this weight is very heavy. This is not 35 kg, it's around 1500 kg weight.
Okay.
So this weight to reduce, you need a controlled thrusters.
The
thrusters, something like whatever helps us to take from wherever the orbit you left to reach the moon.
Correct.
Similar thrusters of 4 numbers. So this is called 800 Newton thrusters, liquid engine thrusters. These thrusters can be, it can be throttleable.
Okay.
Like you are going this car, go the car, you can accelerate or decelerate with that. Okay. So this control will be done by using the thrusters. You fire a full, it gives 800 Newton. You fire off, 400 Newton go.
So because
like that you can control.
A thruster is both like an accelerator and a brake also. So it depends in which direction you are going. It's going to
depending upon that you can do that. So with that mode, the whole trajectory is given once from coming over here. So this will go and land on that place. So this almost everything was going through Chandrayaan 2. But unfortunately, last minutes of that.
Very few last minutes we just.
Okay. We lost the control and it has crashed and landed.
And the objective was Chandrayaan 2 was to?
Softly land.
That is it.
Softly land and then you have a 6-wheeled rover.
Okay.
That rover should come out,
Hmm.
and that is the one will do the in situ chemical analysis. Whatever we have seen from the remote sensing 100 kilometer and while coming, what all you have seen, this effect you should see the in situ.
What Chandrayaan 3's rover is doing right now
Yeah.
was the job of that rover to do, but that rover
he could not.
Unfortunately, could not
unfortunately
land perfectly. And so Chandrayaan 2 happens. The two prime objectives were to softly land.
Correct. Yeah.
And for the rover to find the studies that it's doing in Chandrayaan 3.
Correct. Yeah.
Except that everything was same as Chandrayaan 1.
Except that everything is same as Chandrayaan 1, because there also an arbiter was there in Chandrayaan 1.
Correct.
Here also Chandrayaan 2 also an arbiter was there.
Okay.
So that arbiter is functioning even today.
Okay.
So that portion is doing well.
And what is an orbiter's job, sir? What is an orbiter doing?
No, orbiter job is doing, it is more like what all Chandrayaan 1 has done, but it doing it to more like confirmation.
Okay.
Now the resolution of the images were improved better.
Mm-hmm.
So there we have whatever picture if you take, it's 1 meter resolution.
Okay.
So now it has been made as a 30 centimeter resolution. 30 centimeter from 100 kilometer we can look at that.
Okay.
So the surfaces can be seen better, and the terrain can be seen better.
Okay.
And previously some of the instruments came from US. That instruments now we have done indigenously also.
So those
Chandrayaan
instruments
2.
also now we are making.
Yeah, we are making. So Chandrayaan 2 is a full India made.
Okay.
So there at least 5 instruments came from outside.
Okay.
So that is not here. That is done within India itself. So orbiter is doing its job. But only thing is lander is supposed to have happened, that didn't happen in.
So now to understand this very correctly, sir, Chandrayaan 1 goes into the moon's orbit, does the job of an orbiter, crash lands.
Yeah, fine.
Now we have Chandrayaan 2.
Yeah.
The objective was to softly land and for the rover to find do the studies.
Yeah.
So the orbiter goes into the orbit. Then the sir, what would you call this? The thing coming out
lander,
of
lander.
The lander would come out.
Yeah.
Lander would try and land.
Correct.
But it crashes. But the orbiter still does its job.
Yeah.
So we have got 90% of the mission right, sir.
Perfect. Yeah.
And then Chandrayaan 3 happens.
The Chandrayaan 3, now it is not repeat of Chandrayaan 2, but unfulfilled task of Chandrayaan 2.
So it's also doing the unfulfilled task of Chandrayaan 2 and has its own objective as well.
It is more or less
the objective is the same.
Yeah.
But it's not a repeat.
It is not repeat.
Sir, how is it? How is Chandrayaan 3 different from Chandrayaan 2, sir?
Yeah. The prime objective is unfulfilled task of Chandrayaan 2. That means softly landing.
Correct.
And making sure that the 6-wheeled Pragyan is doing in situ analysis. This is a prime task.
Sir, just a second, a small thing.
Yeah.
Right before Chandrayaan 3, Russia also attempted a lunar 25, right?
Yeah.
What was their objective? How was it different from ours? And how are we, like, their thing is different from ours, sir?
Yeah. Say, if you recall what I initially told, 2009 we started working with Russian. Russia was insisting the prime objective of Chandrayaan 2 is just soft land on the polar region.
That is it.
Actually, that's what they were insisting. But we told we have to go beyond that. That's the reason that we put our rover. So Chandrayaan 2 original configuration launched by our GSLV. Go to the lunar orbit and softly land on the lander. In the lander, we come out with the one rover and do a in situ analysis. Rover will be ours, lander will be Russian. Then there will be an arbiter, like whatever originally that arbiter will be there. So then launch will be done GSLV. GSLV launch India, arbiter by India,
lander by
Russia.
Rover by India.
So they are very clear. They want to land on the safely, because this is a terrain we not landed properly. So we should focus on the landing only.
Okay.
But we told we should after landing we should do something better also. That's the reason we have done that way. So but when they parted away, so I think they continued with the same.
So they did not agree to rover doing its job.
Yeah.
So they said our only objective is to land.
Yeah.
We don't want to do anything beyond that. And we were firm about that. We want to go beyond landing also.
Yeah.
Okay.
Correct. So, but then due to some technical reasons, we could not proceed further. I think they stopped there, and then they went ahead from
with their own mission.
Yeah. So the Luna 20 until then they did Luna 24. Luna 25 more or less whatever we talked about originally.
Okay.
So that, but of course that had some setbacks. Some corrections were done. But notwithstanding that, I think it came around our time frame only.
Okay.
Even I think along with Chandrayaan 2 they have to launch. Didn't happen. Further delays. I think you look at here from 2009 to 2023, nearly they're working for more than 12-13 years.
Okay.
So now they were ready and their launch took place. But their plan is to go for the landing only.
This Luna 25 just wanted to land there.
Land only. But the place is where we are supposed to land.
Okay.
Nearby place.
Okay.
Polar region, South Polar region.
Nobody has landed there before.
Nobody has landed before.
India is in the race. Russia is in the race.
Yeah.
Russia's goal is to only land. Our goal is to land and explore.
Yeah.
Okay.
So that way, objective-wise, definitely we had an edge over that. But notwithstanding that, anyhow, the Luna 25 is started a bit late, but they have the one shot almost going over there. So then the last but one leg, before leg, okay, they are supposed to, the lander supposed to get an orbit somewhere around 30 kilometer.
Okay.
So when they were trying to do, it has gone, corrected more than that. So I think it has gone much below that.
Okay.
So when much below, if you go, if you don't have a controlled thing, this terrain is an issue. Because the terrain is an issue. If you slightly more, if you go, because there are these places, especially poles, north and south poles. You look at here, they are like our Himalayan Alps regions. Ranges, big things are there.
Mountains and all.
Mountains are there. So that can create an issue.
Okay.
Probably that could have happened also because they tried, but unfortunately, due to some reason or other, when they are trying to brake, the thrusters have to fire a finite time. It looks it has fired slightly more.
Okay, it has fired more thrusters.
More. So when you have more duration, when more duration you fire, then it goes more than what it is supposed to have gone. So when we go more than supposed to then, terrain which is not more. Down. It is like some of their crashes happen. Some of their crashes in in mountaineering sections when they happen.
Correct.
It is something like that. It happened there. So that's why ours is very, very calculated. Slow go. And after 30 kilometer, so then we will go gradually. And now Chandrayaan 2 has given a good amount of data. Not only a landing place, even en route also how it should look like.
Correct. So it has kind of defined the entire route for us.
Yeah, exactly.
Which route should we take to land at the place?
Yeah.
Okay. And that data we did not share with the Russians, sir? That is the data that we share with the Russians, or we don't?
No. That mostly the people, the sharing means somebody asks for it will given.
Okay, they didn't ask only.
They didn't ask.
Okay. Yeah. And then unfortunately their lander crashed.
Correct.
And they could not land softly over there.
Yeah.
But then Chandrayaan 3 happens.
Correct.
Because we've taken more time. Just because we've taken more orbits. Because we were going slower. We could land safely on Moon.
Yeah. Along with the lessons learned from Chandrayaan 2.
Chandrayaan 2. Yeah. That is the only. And what is the difference between Chandrayaan 3 and Chandrayaan 2, sir?
Yeah, Chandrayaan 3 and 2, you look at here, the overall orbiter is not a full-fledged orbiter like Chandrayaan 2.
Okay.
Because already Chandrayaan 1 orbiter is there, Chandrayaan 2 orbiter also there. So there is no need once again spend money to make a full-fledged orbiter.
It's called propulsion something like
that? That's why only the previous orbiter has so many systems, including propulsion system and so many science instruments.
Sir, sorry to cut you. What is propulsion, sir?
Propulsion is the one which will help you to propulsion means along with the fuel, the thrusters, other things are there now. The system. So that basically allow you to propel to increase the speed or reduce the speed. Depending upon how you do it.
So, sir, a guy like me would like to understand what a propulsion system is, and what you've told so far, it's like a car with no accessory. Its only job is to accelerate and deaccelerate. That is it, sir?
Yeah, exactly.
So because we had a orbiter there which could do all the findings and the studies, and it had all the instruments in it, this time we just wanted a car to go there that would make the weight a little less.
Weight drastically would reduce less, because other instruments are there for their own requirements.
Correct.
Very, very many things we should do that. Because all the instruments to make it work, and the power system has to be more, battery size has to be more, and many systems are there. So there's auxiliary systems need called upon. And already two orbiters are working. So this is to reduce the work content as well as the budget also will come down drastically.
So
but
Chandrayaan
concentrate on
3's budget is less than Chandrayaan 2's?
Chandrayaan 3 cost is less than Chandrayaan 2 because already the plan is to make use of the Chandrayaan 2 orbiter. For very many things. Selection of the site, and then you for even the redundant communication.
Correct.
It can work as a redundant communication system once lander is landing. So lander can communicate to the Earth. But if it can land in a place, possibly a big crater. Everything may be okay. There are some places happened there also. If they land inside a crater, from there line of sight to the ground may not be there.
Not possible. So it communicates with the orbiter.
Now through orbiter it can communicate. So that provision Chandrayaan 2 still can provide. So that's with that keeping in mind, I think the propulsion system is a satellite with no ancillary systems.
So, sir, a rover that is on ground moving communicates with a lander.
Correct.
A lander either communicates directly with Earth on other ISRO systems, or if it lands in a crater, it communicates with the orbiter, and then the orbiter communicates with the station here.
Yeah, correct.
I've got it right, sir?
Yeah, exactly.
Is there any difference between the rover of Chandrayaan 2 or Chandrayaan 3?
Oh, absolutely.
Exactly the same.
Exactly
the same.
Exactly the same. Except the tricolor emblem added.
Absolutely, yeah.
Other than that, engineering point of view, exactly.
Engineering point, everything is the same.
Yeah, everything is the same.
So Chandrayaan 3 does the mission of Chandrayaan 2, completes it's trying to achieve the unfulfilled task of Chandrayaan 2 with using Chandrayaan 2's orbiter only for communication if needed.
Correct.
Otherwise, it's pretty much the same mission.
Yeah.
Little less costly.
Correct.
And
yeah.
Successful.
Success.
That's amazing, sir. Now, sir, let's dive into the day when we are about to land. Sir, I want to get a picture of that day.
Okay.
What happens when it's the day of landing, sir?
Correct.
What are the heartbeats? What are you guys going through? How are the things in the station? What is happening, sir?
Yeah, that particular last leg is a very, very crucial thing.
Okay.
Like your flight, you are cruised there, and you started from Delhi. You are getting down Washington.
Okay.
So already our July 14th you took off, and you're cruising through that.
Okay.
So then Washington comes. Then you put the belt thing, everything there.
Correct.
Then you will keep on. It takes around 20-25 minutes normally it takes to come down.
Okay.
So he gradually reduces speed. So in that process, further away itself, he loses the altitude and reaches the place, and he can go growth like that. But unfortunately, in our system, nothing called the wheels you can roll down like that.
We cannot
do that.
Because there is no plane, we don't know the terrain.
Yeah.
Okay.
So it has to land on a leg.
Like a helicopter.
Like a helicopter. It has to land like this only. But now, while going, it has to, it is to start with, it is some 30 kilometer height. Around 20 minutes away. You give go. So then by the time all the required instructions previous last 2 days could have been uplinked to the onboard.
So for landing today, we have to upload all the instructions 2 days before.
Yeah. 2 days before. That tells each time, each instant, how much velocity you have to reduce. And when you are realizing velocity, how much altitude you expected. And at that point, what you expect the terrain. And what orientation you are supposed to be.
Okay.
These are all the instructions given.
Correct.
So now and these instructions have been uploaded. And once again, read back ground and make sure that everything is pakka. Because especially the failure happened few days before the
Lunar 25 failure.
One of the possible failure is the extended duration. Extended duration possibly could have been one of the parameter could have been got corrupted.
Correct.
That possibility there. So that's why doubly, triply you make sure that whatever you uploaded, all the parameters, all the memory locations, bit by bit is okay. So that verification. So 48 hours before starting. So everything done there. So then the time comes, you give a cue, go. Okay. So then it starts. Then afterwards, no interruption from ground. So as per the instruction.
Okay, while it's landing, you cannot do anything.
You cannot do anything. You cannot do anything.
Because, sir, how much is the time that it takes for a signal to reach from here to the moon's, like if there is a lander at moon, in the orbit of moon, how much time will it take, sir?
It takes 1.5 seconds. 1.5 seconds.
Then why can't we control it, sir, when it's landing? Sorry, it's a I know it might be not a good question.
No, it's 1.5 seconds assuming that just going alone.
Okay.
But to come back, so then you have to think what to do.
Correct.
So it's a steering, such a thing is difficult. And that too, steering is not one steering.
Correct.
There are 4 thrusters. All 4 you have to decelerate or accelerate.
Correct.
Okay, you are given the 4, even your video game, one steering you can do. 2 you can struggle. Now you are 4 steering assume. 4 steering 4 brakes. It's an impossible task.
Correct.
And you have to look for the terrain in the speed which is going is nearly 1.7 kilometer per second. Nearly 10 times faster than our normal aircraft.
Correct.
More than 6,000 kilometers per hour. Okay, our normal aircraft landing, whatever I told you, 600 kilometers, he stops. Okay, then you keep grabbing down.
Correct.
So now 10 times faster is going, and it's going to be a tough situation. So that's the commands are given there. So then another possibility is when it's going, there is a possibility sometimes your communication may get into problem also. We cannot afford to have mistakes.
Correct.
So what all we will do? So what all, even if you are online, what all your foreseen issue and forward, how you will react, everything has been embedded on the system.
Because in every minute and every second, situation might change
Might
completely.
change.
You
We can
a human mind it's difficult for a human mind to process that.
That is the basic difference. Is see, I told every mission of this category, once you execute your plan A, plan B should be there. So here, this period of 700 kilometer range to come down 30 kilometer this way, 700 kilometer this way, 30 kilometer this way. Around 20 meters. Now every segment is broken. Everything has a plan A and plan B. Okay. At this time, you should be here. This velocity, this orientation, and your surface, what you are seeing, should be like this. If it is not, why it is? Maybe the thruster has fired less or more.
Correct.
You correct it there and try to get back the plan A.
So we can correct it while it's
No. The instructions are given like that.
Okay, so it has to do it on its own.
It is more like artificial intelligence trying to look for, yes, I am going at this point, I am going this velocity. That will be sensed by some system, and I am this height. That's all sensed by the system. And I should see already a loaded picture.
And if that's not happening,
this picture is not happening, then it will understand why it is not happening.
And then switch to another plan. Okay.
Plan correct back to the next level.
Okay.
So like that, each segment you will be there. So if you closely watch the day, the parameters, how it is going, you can understand. So when it's gradually going, original thing is all thrusters are firing.
Correct.
So these velocities keep coming down.
Correct.
That's perfect. Okay. Then slowly you can see it's keep falling also.
Losing the height
also.
Yeah.
But in some places we expected, we may be going more than what we expected. Then it comes back. That small orientation change comes back. Some bouncing you can rotate there. Okay. So that's where it's keep coming. So when it reaches that way, so then at one particular place it turns.
Okay.
And it takes some pictures.
Okay.
Then it is trying to see how where
how's the
going.
land over there?
No, that's still further. Okay. Still further. Now what is happening is now it adjusts how much time it takes to go that place.
Okay.
It sees that. So my orientation should be what way? Because now this orientation, I can reduce this fall. Now slowly it's trying to fall.
Okay.
I have to go. I should not fall too much.
Correct.
Okay, but I reach the place.
Correct.
Okay, so that way it try to modulate this orientation such that one way it is gradually reducing the speed until it reaches to not become zero.
Okay.
Until it reaches. Okay, Chandrayaan 2, before reaching it becomes zero.
Like
created some issue.
A meter above the ground, it should reach zero.
Yeah. So it goes up to there. Somewhere 800 meters should be there. So until then, this height will be there.
Okay.
But you are not reached there.
Okay.
So then it turns. Then it turns. Then it falls around 50 meters also goes. Then it tries to look for that place whether I am. This place I reached there. Okay. And that place is safe also. Okay. If it is not safe, it move other place. Okay. Could have seen mission. Yeah. First place didn't land.
The Chandrayaan 3 mission? Yeah. Achha, we didn't find
the
right place in the first time.
Target be selected.
Okay.
You would have seen that sign.
Okay.
You would have seen that it has selected another target. Okay. So it moves there. So every instant.
And how far these both targets were, sir, in this mission?
I think around 50 or more than 200 meters. I think.
Okay, that's 100 meters.
200 meters. So another target is moved.
And what was the problem with the first target location, sir, if you can tell?
Where first?
Sir, the Chandrayaan.
Yeah. Basically, when it's seeing, so initially we have taken the images with respect to reference images with respect to Chandrayaan 2 data. Okay. Chandrayaan 2 data can differentiate anything better than 30 centimeter difference. It can differentiate. Okay. But a boulder is around 20 centimeter. You cannot locate. Okay. Got it. But now that is from 100 kilometer. But now you are sitting with 50 meter. 50 meter I can see much better. Much better. Yeah. So we don't want to see a pit more than 20 centimeter. Okay. And even a stone more than centimeter. Why unnecessarily go and land there? Okay. So that sees. And accordingly it moves other side. Okay. So it sees. So basically.
And then it found a perfect land to land upon.
Yeah. Okay. So this similar situation, many times it has been tested on ground. Chandrayaan 3. Okay. Chandrayaan 2, we cannot tell that way to happen because every instant plan A, plan B, you try to correct. Now you run through that. It is doing that. It was doing all along. And finally, even the landing place also it is in because the landing place, Chandrayaan 2 was only 500 meter by 500 meter. Okay. Very, very tough to locate. Okay. After going over there. But here with the Chandrayaan 2 data available, we could select a place called 4.5 kilometer by 2.5 kilometer. wider
Much
region,
bigger place.
much bigger.
Much bigger
So
place.
instead of this place, now you can land anywhere.
Okay.
So now you go there. If not there, you can land there. You
Okay.
can land there like
Okay.
that. Like
And
that.
this we were able to select this because of the orbiter's data
Exactly.
from the
exactly,
Chandrayaan 2.
exactly.
Okay, sir.
So that way, 2 and 3 combination is come in a nice.
So while this landing is happening, sir, when we see this landing in the on the news and everywhere and the films also, so all that scientists can do in that moment is to pray that it lands safely.
Yeah. Because
Nothing else. You can
no. Nothing else means there are. I told na, each one has his own contribution. Whether his contribution, how it's performing, he is looking for.
They are just collecting the data now.
Yeah. They are looking at the data. You can see that some place the gravity is trying to pull, trying to come up.
Okay.
And it reduces the velocity. Okay. And then it's trying to see the terrain also, whether the terrain is matching it or not, and the altitude is matching it or not.
Correct.
So these are all the parameters that
So everybody is just checking the
just
data.
checking whether is it coming as expected. If not expected, whether it corrects back or not. Actually, it is correcting back. That is more important is wherever not coming, it was correcting back.
Okay.
That is the best part of the whole system.
Correct.
The best
So
part of all system.
if it has a good capacity of fixing what has gone wrong,
Yeah.
it's going to land safely.
Correct.
Okay. Very beautifully explained, sir. Chandrayaan 3, Chandrayaan 2 and Chandrayaan 1. Now Chandrayaan 3 lands and the rover gets out.
Yeah.
Sir, so far what are our findings and what has happened, sir?
Yeah, so far you look at there basically the one of the thing is one reflector has been kept there.
Okay.
So that will work for another 70-80 years.
Okay.
Because the moon is not going around the earth. It is not coming year on year the same orbit.
Okay.
It gradually is moving away.
Moon is moving away from Earth.
Moving from the earth.
So there will be a time when Moon will be out of Earth.
Yeah, because once upon a time it would have been very close. It is going away. So they want to quantify that. So a retro reflector being kept during Apollo time.
Okay.
That means you keep a cluster of mirrors type of thing.
Okay.
So from here, ground you send the laser pulses.
Okay.
And it goes and reflects back.
Okay.
The time between
calculate
these
the
two
distance. Okay.
So that shows every year few centimeters it's keep receding from the earth.
A few centimeters.
Few centimeters.
Then to lose it, like to lose Moon will take
a
lot of time.
But still we would like to know the dynamics to know.
Yeah.
Okay. So that system whatever kept is because of the dust other thing. It's losing its reflecting power.
Correct.
So now there is a time for us, and I think a new reflector being kept as a part of the lander. Okay, a lander. So that will help for another 78 years.
Okay.
So but remaining the lander where it landed, it is trying to assess the soil properties of the moon.
Okay.
One such thing is to understand the thermal properties.
Okay.
How the thermal system is conducting, something like that. So because of sun heat, it gets heated surface. But how below the surface, okay, when we keep going down, the probe can measure every centimeter what is the temperature you are seeing.
Correct.
So this now you look at here the surface temperature, whatever we see, it's keep falling very drastically after 5-6 centimeters itself. Okay, 8-9 centimeters itself, 8 centimeters itself, it is somewhere around minus 50 degree it has gone. Whereas the top is around 40 degree.
Just below 8 centimeters it has gone down?
Yeah.
So top is how much?
Around 40 degrees.
40 degrees.
40 degrees.
And 8 centimeters below it's minus 50 degrees.
Yeah.
On Earth, sir, what would it be like?
Yeah, but on Earth you don't see that. That's why when we dig even wells and all you dig,
there is
and
no
put the things we are not seeing
hardly any difference.
Hardly any difference. Okay, so because this sort of properties are required to understand when we are trying to go so some permanent structure, something like that we want to do.
Correct.
We should understand that.
Okay.
So even pipelines you put here, let us assume the pipeline cannot withstand. One side you have a 40-50 degree temperature, another side minus 50.
It's gone.
It's gone.
Correct.
So but ground is not like that. But there it is there. So that is one of the things. But another good thing there is whatever the water would have been there below, whatever the connection goes below the surface, that can be preserved because of the temperature.
Because it's going to get frozen.
Frozen at that.
It will never evaporate.
Evaporate. So that is another good thing is possibility of subsurface water even in the sunlit region cannot be ruled out.
Correct.
Okay, we thought only cold trap regions we have seen, but this temperature difference, whatever it shows, it's giving one thing. Even if it is not there, for example, far-reaching time frame, we are thinking about, people are talking about a possibility of launching the launch vehicles from Moon to Mars. Because
Correct.
Mars colony also we are talking about that.
So Moon is going to be a station in between.
So when it being a station, you need, because a normal rockets not possible. You need a system where cryogenic engines more to be used. Maybe full-fledged cryogenics. Cryogenic engines calls for hydrogen, oxygen in liquid form. Now, water is available. Now you have just few 1 meter away, your sub-zero temperature is available.
Correct.
So with put together, you take
enough,
water, make it hydrogen, you make it oxygen,
correct.
you store it in the same place.
And then tomorrow you'll have a station there. You can use that as a fuel. You can convert that again into liquid form.
Yeah.
And you can launch to Mars.
To Mars. So that's what possibility exists. So that is the thing. So that is one of the finding itself. It flowers out in a big way.
Okay.
And similarly, you look at our rover. Rover has two instruments. Two instruments is not only just seeing the surface. It creates a phenomenon.
Okay.
In the chemical laboratories, you look at here, they will give a salt, ask for the salt. What is the salt? We may mix with water and see, or we heat it and see. So many things you will do and see that.
Okay.
But here the two instruments are having something called laser-induced breakdown spectrometer.
Laser-induced
breakdown spectrometer.
Breakdown spectrometer. Okay.
So that is then another instrument has an alpha source.
Okay.
That creates an X-ray. Okay. So then this gives X-ray, this gives laser pulse. These two things can alternatively one place it can hit. So when it hits, it will create an action on the system. Physical changes takes place. So then that atomic numbers can come out. So the spectrometer look into that. Look for what is that surface contains. What is the chemical properties of that place? So that is now, again, you would have seen the graphs, whatever is showing, the presence of silicon, iron, titanium, sulfur,
correct,
and oxygen also.
Correct.
Okay, that oxygen probably I feel it could have been the oxide form, could have been in any one the system. That's also coming out there. Okay, so this is how now what we are seeing this. Then alpha source we are about to get calibrations going on. So that also will come out there. So these instruments will do something called in situ what we have seen 100 kilometer above.
Correct.
So now we are trying to see from the surface itself. So this 6-wheel rover will keep on moving as per the ground command. It has its own camera. It takes the camera output and throw lander to the ground. So from ground, people will see how the front look like. Then we'll try to steer.
Correct.
This way or this way, this way you can steer. And steer and go every 10 meter type of thing you go on that place. Because the lander where you landed probably would have got polluted chemically.
Correct.
Because of various reasons. Its own liquid engine problem.
Correct.
So instead of that, it will move away. And around the place, it will keep going.
It will not have any impact of any other chemical. It will be completely...
Yeah, that is a pure...
Yeah. And then it will do all the experiments.
Yeah, all the experiments. So that data...
How far can this rover go, sir?
No, this can go up to 500 meter.
500 meter this can go.
Because afterwards, what is happening, it goes down.
Correct.
Your line of sight will not possible.
Okay.
From the lander, because lander is only very short. From that line of sight, not possible. So that is the thing. So we expect some 14 days of thing. Because the place where we landed, because most of the places on the moon will have the daytime ground equivalent 14 days. And 14 days night will be there.
Okay.
Because it's going around the earth. That is the way it's happening. So it will happen 14 days. In revolution is 28 days.
Okay.
Earth is 24 hours.
Okay.
So there are 28 days.
One moon day is 14 earth days.
14 earth days.
Yeah, correct, sir?
Yeah. It will survey only one moon day now.
Okay.
Yeah.
So it's going to survey only one moon day.
Only
so it's only going to survey 14 earth days.
14 earth days.
That is the life of this project.
That is the life of this project.
Okay, I got
Nominally.
It might perform better.
Yeah. But now what is happening is we have made, because with the team, I worked out that initially itself, starting from PCB, many materials, some special attention was given. Even if it goes to 200 degree minus Celsius, well, to make it survey. One thing. And second thing is, even if it is some of the electronics, we are finding it difficult. So we are trying to keep them as close as possible so that temperature will not affect.
Okay.
So that's why the last day of the thing, with this orientation of the rover will be kept such a way.
Okay.
After 14 days over, when it hits, sunlight has to hit there, like that.
Okay.
And the solar panel which has been opened and kept
Okay.
will be closed there. So that will come like our coat.
Okay.
We'll try to
For the rover.
For the rover.
Huh.
So that will be kept that way.
Huh.
But as far as lander is concerned, nothing we can do. But many of the systems have been tested, but that we have to check now. Even the solar panel, minus 200 degree and all, we have not seen. Normally not seen. So because the long duration. So those things have been tested and kept. Then we have the circuit called sleep circuit. We'll try to switch off all the systems so that it will not draw the power from the battery.
Okay.
And whatever minimum power is there, whether it can keep it, the systems as much as possible.
Okay.
So next day when it comes, sun anyhow will come, whether it's functioning or not functioning. So when it will get enough heat. So a circuit is called wake-up circuit is there.
Okay.
That circuit just measures temperatures of the various system.
Okay.
If the temperature of systems are good enough, then it will turn on the system.
Okay.
So the circuit has been tested.
Okay.
So the circuit is alive now.
Okay.
Okay. The circuit will be alive here and here. Make it sleep and try to wake it up there. If it works, then another 14 days will work.
Otherwise 14 are for sure.
14 is sure.
Then another 14 if this thing works. If the temperature of the instrument is fine,
correct,
then it can go for another 14 days.
Yeah, because many of the systems have been tested even for the low temperature, it can work. But some of them we have not done.
Correct.
Okay. But we are taking a chance now.
Correct.
If it works, works.
Correct.
But to make it work, we have made some special circuit.
Okay.
That circuit has been tested, putting for the low and high temperatures.
Perfect, sir. Perfect. So that's
So
great.
we have to wake up now.
Yeah, no. Or wake up, sir. I have never been exposed to this kind of knowledge and never understood these missions in such a way.
Okay.
We have just known Chandrayaan 1, Chandrayaan 2, Chandrayaan 3, but it's such an honor to know about these missions. Chandrayaan missions के बारे में हमने न्यूज़ पे देखा था, बहुत बुरी तरह से देखा था, बहुत गर्व महसूस हुआ, बहुत कुछ जाते थे, समझते थे क्या कुछ? चंद्रयान मिशंस क्या थे? क्या सिर्फ चंद्रयान 3 इंपॉर्टेंट था, चंद्रयान 2 इंपॉर्टेंट था या चंद्रयान 1 इंपॉर्टेंट था? All Chandrayaan missions were very, very important. And nowhere on YouTube you will find this kind of explanation from the man who has created Chandrayaan missions. तो आपने ये पॉडकास्ट देखना है, कमेंट करना है, तारीफ करनी है हमारी और कुछ नहीं सहेंगे. तारीफ करनी है हमारी, जेके सुपर पॉडकास्ट की तारीफ करनी है आपको, क्योंकि ऐसी इंफॉर्मेशन चंद्रयान मिशंस पे किसी ने ना दी है ना कोई देगा. प्लीज लाइक करिएगा, शेयर करिएगा, सब्सक्राइब करिएगा, सर को फॉलो करिएगा. Thank you so much, sir, for doing this with us. It was an absolute honor.
Thank you.
Thank you so much, sir.
Thank you.